Good afternoon, everyone. Today we're going to be covering Activity 3.3, Compound Inequalities. I want to remind you guys that if you were in class today, we already went over the entry task, but if you did not, it is your responsibility to try this one out. That is how I gauge how you guys are doing on these problems. So make sure that if you are remote today, that you are completing that by the time you turn in your guys' notes. All right, so let's start with what is compound inequalities. Now, a compound inequality are just two inequalities combined with an or statement. So if you see at these bottoms here, the two bottom here, I have an and statement here and I have an or statement. I have two inequalities each that are combined with an and or an or. Now keep in mind that when we are doing these compound inequalities, try to always keep in mind kind of like common sense in a way. If your parent says, hey, you can have this toy and this toy, that means you can have both. If she says, hey, you can have this toy or this toy, that means it has to be one or the other. And you'll see where that comes into play once we start graphing these and start analyzing exactly what these compound inequalities are. So let's start with the and. So if I read this inequality starting right over here, I know that x is greater than or equal to a negative 5 and it is also less than 10. That means that they have to be both, that I have to have both of these inequalities. My solution isn't just one inequality or the other one, it's both. Now, some people can read that inequality and understand exactly what numbers you're talking about. What are my answers that they have to be both? Well, then that's why 99% of the time we're going to do some type of graphing because it's so much easier to see this visually. So let's get to graphing. So x is greater than or equal to negative 5. I know that negative 5 is right over there. It's going to be a closed dot because it is a greater than or equal to. And remember, your x value is greater than. That means it's going to be pointing to the positive direction going this way. Notice that it also has to be less than 10. So here is my 10. Remember, your x is the boss, your x is less than, so that means it's going to be pointing to the negative direction because it's less than. So just analyzing that for a second, keep in mind that in order to graph this compound inequality, your solution has to be answered to both. It has to be this and this. So that means that it has to be everything in the middle, everything where those two arrows would touch. And notice I tried my best to cancel out those arrows because you have to erase the arrows. If you have an arrow, it means it's going on forever and ever and ever. Unfortunately for us, for these ands, you won't be able to do that. So what does this do for me? Remember, you have an inequality that has two, or you have a compound inequality that has two inequalities. Anything in that little line is a solution. If you pick 0 here, is 0 greater than or equal to negative 5? Yes. Is 0 less than 10? The answer is yes. So that is why we graph these compounds, and this is how pretty much how they work. There are two inequalities in one. Let's do the next one. Notice that this is an or statement. So first one I'm going to do is x is less than 0. So here is my 0. My x is less than, so it's going to be in the negative direction of my inequality. Now I'm going to go ahead and graph my second inequality, which is x is greater than 5. So here is my 5. Let me double check to make sure it's, close circle, forgot that there was a greater than or equal to. Now your x is greater than, so it's going to be pointing in the positive direction. So what is a solution here? Remember, like how just kind of common sense of or. Your solutions are in this location or in this location. It can be either or. It can be one of those, but it can't be both at the same time. So notice that these two are very distinct. When you have an and statement, your solutions are always kind of contained in the middle. I always call them like an interval, an and. That is what we like to call a conjunction. They're connected. An or statement is always a disjunction. It's going to be going one direction and your inequality is going to go the other direction. We call that a disjunction. So makes a lot of sense though, because if you choose somewhere in the yellow there, something that's a solution like 10, remember that in order to be a solution, it could be this or that. If you put 10 here, 10 is greater than or equal to 5, technically you've already answered your solution already. So that's the basics of what a compound inequality are. Let's start doing some just basic graphics. So I want you to create a compound inequality for all numbers greater than 0 and less than 4. So I'm going to start with my 0 because I need to show my reader that if I start at 0, my solution, all the numbers that are greater. Now I always like to put a plus to my right and a negative to my left, so that way I can see the positive and negatives. So all numbers greater than 0 are going to go in this direction. But keep in mind this is an and statement, so I know there's going to be a conjunction. So it has to be less than 4. Now here is my 4 right over here. My less numbers are going to go to the left, so I know it's everything in the middle. My suggestion is to always erase it, so that way you can see it there. So let me change colors so that way I know you understand where the compound inequality are. My solution is everything in the middle there. All those numbers like 2, that is greater than 0 and less than 4. So that is how you graph a compound inequality. Let's go to the next one. All numbers that are less than 2. So here is my 2. All numbers that are less than are going to be in the negative direction, or greater than or equal to 4. Well, here's my 4. It's going to be a closed circle. Remember, I'm trying to look for my solution. All the numbers are greater, so it's going to go towards the positive direction. And you can see that I choose anything in the left or the right, and that is going to be a solution to the top one, or at least one of them, or the other, because it's an or statement. Now, I want to make sure to clarify that 99% of the time when you have an and statement, it's always going to look like that. It's going to look like a conjunction connected, and an or is always going to be a disjunction going the opposite sides. So let's do the last 3. All numbers that are less than 2. So here is my 2. My less than numbers are over there, so that represents that. And greater than 8. So here is my 8, and it is greater than. Now, let's analyze this for a second. All numbers that are less than 2 and greater than 8. Now, remember what I just told you. This is a conjunction because it's an and statement. That means I should get something with 2 circles and answers. Now, does that mean that if this happens, what does that mean? Does there exist a number that is less than 2 and greater than 8? No. So that means that there is a no solution. So that's what's really nice about visually graphing these, because it makes it a lot more obvious. Next one, all numbers that are less than 8. So here is 8. All numbers that are less than are in this direction, or greater than 0. So here is my greater than 0 and this one over here. My greater than numbers are going to be pointing to the right. Now look how tricky this one is. So if you go all the way, remember, it could be this or that. So notice it covers everything, because this is an or statement. It could be that or that. So that means this is all solutions. So keep in mind that there are 4 things that could happen, and I just I did show you this. If you have a common, now, to be honest, 99% of the time, they're going to work out very nicely like that. But you need to be able to analyze those solutions and understand the or and the and statement, so that way you know if it's a no solution or all solution. So let's do some example problems, so that way you guys could go ahead and. All right, so I'm scrolling down here, and let's start from here. So these are pretty much compound inequalities with a little bit more work. You'll notice that you technically already know how to solve these. Let's just what you're doing here with these compounds, you're solving 2 and 1, and that's it. Now ignore these 1s and these 2s here. My numbering was off a little bit because I copied and pasted them, so just ignore them. Notice I have 2 compound inequalities. One is k over 4 is greater than or equal to 1, or k over 3 is less than or equal to a negative 1. Now remember what I said about or statements. An or statement is a disjunction, so that means that I should have some type of interval going one direction and the other, if this is just a normal compound inequality, which 99% of the time it is. Now when you have an or statement, you have 2 inequalities. It is your job to solve each one at a time. So let's solve for this inequality to the left, solving for k. Remember that when you have a fraction that's just a division problem, that 4 is just dividing, so the opposite would be to multiply by 4. These 4's cancel out. K is greater than or equal to a positive 4. So that means your solution to that inequality is when k is greater than or equal to 4. So here's my 4, close circle because it's equal to as well, and my k's are greater in that direction. Now let's solve for this k here, multiplying by 3 on both sides. I end up with k is less than or equal to a negative 3. Negative 3 is over here. My k is less than. So remember that these solutions are when your k is less than or equal to a negative 3 in this direction, or when it's greater than or equal to 4. So are these problems a lot different than what you covered before? No, there's just, how would I say, 2 problems in one. You're doing 2 problems in one, exactly. So let's do the next one. So notice right here that I have 6 is less than or equal to x plus 6, which is less than or equal to 11. Now, you'll notice here that you have 2 inequalities together. You have the inside stuff that's greater than or equal to the 6, but less than the 11. Now, my suggestion for you is to split up the inequalities so that way it's more visually obvious that there are 2 inequalities. So I'm going to start with this one. My x plus 6 is greater than or equal to 6. And notice that I just pretty much wrote it down there. I wrote this guy down because that's one of my inequalities there. Now I'm going to go ahead and write the other one. This is my second inequality here. X plus 6 is less than or equal to 11. So whenever that is, you have two inequalities in one. That is an AND statement. Okay? So when you have an AND statement, you should have an interval that looks something like that. Let's see if we could solve these and figure out what those intervals are. So minusing 6 on both sides to solve for that x. You end up with 0 is less than or equal to x. So if I were to graph this off the bat, here's my 0, close dot at the 0. Your x is greater than, so it's going to be going in this direction. Now solving my second inequality, I'm going to minus 6, x is less than or equal to 5. Here is my 5 in this interval, and then it's less than, so it's going to go in this direction. Now if I were to see that, unfortunately, I would have to mark you wrong. Because remember, this is an AND statement. It means it has to be this and that. This inequality and that inequality. Those arrows mean it's going forever and ever and ever. So if I read this arrow, it means it's going forever that way. So you need to make sure to erase those arrows and draw a solid line to let me know my solution, those solutions are in the middle. So what does this mean for me? Again, choose any number inside of that interval, pull it into this equation, and it's going to be true. All right, I'm looking at my next one here. I have 6 is less than or equal to x plus 6, which is less than or equal to 11. I see that I copy and pasted the exact same one, so I'm going to ignore that one. Saved us some time there. I think I did at least. Yep. All right, so now one more example and we'll call it good. So we have number 4 / number 16 here. And I have two inequalities connected by an AND statement. So I know that it's going to look exactly like this, but I have to do the work for each one. So 4a plus 8 is less than 11a plus 15. So that is one of my inequalities. You need to solve one at a time. There's no distribution. There's no combining like terms, but I do have a's on two sides. So I'm going to move the smaller a over by minusing 4a on both sides. 8 is greater than or equal to 7a plus 15. So for that a, I'm going to minus 15 on both sides. I end up with a negative 7 is greater than 7a. Dividing by 7 on both sides, negative 1 is greater than a. So that is one of my solutions. I could graph that already. Negative 1 is right over here. It's going to be an open circle. Your a is less than, so it's going to be pointing in the negative direction. One more. 13 minus 4a. Let me write this over here so that we can see it clearly. 13 minus 14a is less than or equal to 13 minus 3a. Moving the smaller one over, I can see there's no parentheses to start off with, right? No combining like terms. So let me move the smaller one over. 14a on both sides. I end up with 13 is less than or equal to 13 minus, this was 14, plus 9a. Now minusing 13 on both sides, I end up with 0 is greater than or equal to 9a. Dividing by 9 on both sides, 0 is less than or equal to a. So where's my 0? My 0 is right over here. It's going to be an open circle. My a is greater than, so that means it's going to be pointing in the positive direction. Now remember, this is where you always have to analyze. You just can't graph them and be done with it. Remember that this is an AND statement. So where are my solutions? Both, because I have to have both. They're AND, right? This and that. Notice that there is no common solution, so that means that this one will be a no solution. And that's it. So we are going to spend 2 days on this unit, just kind of making sure we know how to do the compound inequalities, because this is just analyzing the solutions the hardest. So taking a step back, hopefully we'll get that down a little bit more.